Our fourth type of reaction is a double replacement reaction. And if replace means to switch, it means we are switching two things. We are exchanging basically the positive ions between compounds. And the only way that this can happen is if we have two aqueous solutions. And aqueous means made with water. So in general, we have our two compounds, AB and CD, and we are going to swap our possibilities. Now remember, it's always going to be your cation first and your anion second, your metal cation and your nonmetal anion, and you have to maintain that on the other side. So if it's A plus and B minus and C plus and D minus, basically A and D get together, plus minus, and C and B get together. And make sure you see that clearly, all right, because C has to be a positive charge there, okay? Now, when you are doing a double replacement reaction, and it's going to be successful, you have to have one of three things happen. You have to either make a precipitate, you have to make a gas, or you have to make a molecular compound. Basically, you have to make water. Okay, so a precipitate is going to be a solid that is formed out of a solution, like silver chloride. That's going to be that solid that we see fall down into the bottom of the test tube. All right, and you're going to see it get all kinds of cloudy. Okay, a gas is formed, and that's going to be H2S gas. That's the only one that you're going to be required to know. And the molecular compound is H2O. So you got to ask yourself three questions. Is it H2O? Is it H2S? Or is it a precipitate? Well, H2O and H2S, O and S are right next to each other on the periodic table, top and bottom. So how do I know if I make a precipitate? Well, I have to check the solubility table. And a solubility table shows you the solubility of two ions in one another. Okay, the cations are going to be on the left and the anions are going to be up along the top. And where they intersect, we'll either see an S or an I. S here stands for soluble, not sulfur and not solid. Only on the solubility table does soluble stand, or S stand for soluble. So that means that these two substances form a solution, and you can write an AQ after it. I means insoluble, and if you look, an I is the beginning of a downward arrow, showing that it falls down and precipitates out of the solution. All right, this right here is a website where it has our solubility. I'm going to exit out of here so that you can see what this table of solubility is going to look like. Okay, so if you have K plus and I minus, you can see whether or not a compound forms, whether something is going to be insoluble is going to be white, so AgPO4 is going to be insoluble, but AgF would be soluble, etc., etc. There's some compounds that don't exist in water, and that takes a little bit more chemistry to figure out. But the solubility table that I give you, I print out ever so nicely like this. And up here is the key for you. All right, you have your soluble for S, your insoluble for I, D decomposes in water, U, it does not exist or is unstable. A with a, or I with a little a, it's soluble in acids, and I with a B, it's soluble, slightly soluble in some acids, and if there's an H2O there, it produces water. All right, but what you're looking at here is seeing what happens when you link up your cations and your anions. So again, your anions are across the top over here, your cations are down below here. And what you'll see is if you have Al3 plus and I minus, that means it is soluble there. But aluminum and your oxalate is going to be insoluble. Okay, if you have H and OH, you'll see that you make water. Whether it is H and OH, those are going to be your two possibilities right there. And you'll see that there are lots and lots of examples for these guys, they're all worked out for you. If something isn't on here, you can always go through your general solubility rules, which also can help you as well. All right, so if we go back to our presentation, okay, you'll see what we're talking about here. So if we have NaOH and H2SO4, the Na and the SO4 and the H and the OH get together. So again, Na2SO4, look it up on my solubility table, it's aqueous, and H plus and OH minus makes HOH, and HOH is the same thing as water. So I made water, and it's a successful reaction. BaCl2 and K2CO3, the outsides come together and the insides come together. I call it like the chemistry foil, outsides and insides. So BaCO3, I looked that up. Here's my precipitate. K and Cl, that's aqueous, but I at least have one precipitate, so that is successful. And then I have FeS and HCl, so I have my outsides and my insides come together. H2S, that is my gas, and FeCl2 is aqueous, so that is successful. So what happens if it's not successful? What happens if you look and there's multiple things that are soluble? Okay, on your solubility rules, you're going to find that almost all of the nitrates are soluble, all the potassiums and all the sodium compounds are soluble. Okay, so that means NO3, that means K plus, and that means Na plus are all going to dissolve. Okay, I print them out on salmon colored paper, so you'll see that you can consult that. If there's no precipitate, no gas, or water, there's no reaction. So if you have AgNO3 and KCl, Ag and Cl, and your K and your NO3, both of which are aqueous, you simply put a line through it and write no reaction. So definitely always check your solubility rules. I put the single replacement activity series on one side, solubility table on the other side. All right, so if you see your two compounds, AB plus CD, they're going to be aqueous, and then we're going to wife swap them, switch them out. So look at the ions, switch the cations by doing the outsides and the insides together, make your neutral compounds, and then ask yourself the three questions. Did I make water? Did I make H2S? Did I make a precipitate? Okay, how do you tell if it's a precipitate? You look at the solubility table. The S means soluble, the I means insoluble, and then if it's successful, balance. If not, it's no reaction. Okay, so let's try a couple out. Here we have HCl aqueous and KOH aqueous. So ions, H plus, Cl minus, K plus, OH minus. Outsides and insides. Okay, H plus OH minus makes H2O, and K plus Cl minus makes KCl. All right, ask yourselves the three questions. Okay, did I make water? Did I make H2S gas? Or did I make a precipitate? Okay, you always ask yourself those three questions. So did I make water? Yes. So I'm going to put liquid here for water. Now what about KCl? All potassiums are soluble. So that's an AQ. And then you are good to go. Is it balanced? Yes. So it's all ready, Freddy. Okay, FeS aqueous and HCl. Fe here is a 2 plus, S is a 2 minus, H is a plus, Cl is a minus. Outsides come together, insides come together. So Fe2 plus, Cl minus, I get FeCl2, and then H plus and S2 minus, I make H2S. All right, ask yourself the three questions. Did I make water? No. Did I make H2S? Yes. If it's a gas, it's going to bubble out of the aqueous solution and gases are going to rise. FeCl2, if I look on my solubility table, that is aqueous as well. And then I can go through and I need a 2 in front of the HCl in order to be balanced. Good. All right, KCl and NaNO3. K is a plus, Cl is a minus, Na is a plus, NO3 is a minus. Outsides, insides. K plus NO3 is KNO3, and Na plus Cl minus NaCl. All right, ask myself the 3 questions. Did I make water? No. Did I make H2S? No. Did I make a precipitate? I don't know. Let's check the solubility table and the solubility rules. All potassiums and nitrates are soluble, so that's AQ. All sodiums are soluble. This is AQ. So if I have AQ, 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 all 4 aqueous, it's just a bunch of ions floating around, there is no reaction that is successful here. All right. Lastly, Al2O3 aqueous and AgNO3. So this is Al3 plus O2 minus, Ag plus NO3 minus. Outsides come together, insides come together. I get AlNO3 taken 3 times, and Ag plus and O2 minus is Ag2O. Ask yourself 3 questions. Did I make water? No. Did I make H2S? No. Did I make a precipitate? I don't know. So, rule-wise, all nitrates are soluble, so this is AQ. But if I look at the Ag and the O2 minus, I find that there is an I there. So here is my precipitate. Yay! I am soluble. Now all I need is to balance it. And I'm going to balance it by putting a 2 here. And then I have how many nitrates? I have 6 of them. So I'm going to need to put a 6 here. And then I'm going to need to put a 3 there to balance out the Ags and the O. And we are successful. So those are our double replacement reactions. Okay, here again are the answers in case you can't read my writing. Always, always, always use your ions. They're never going away. Okay? So I have H plus and OH minus, K plus, Cl minus. I successfully made water. That is one of my 3 requirements. Fe2 plus and Cl minus, H plus and S2 minus. I successfully made H2S gas. That's one of my requirements. K plus and NO3 minus, Na plus and Cl minus was unsuccessful. No water, no precipitate, no H2S. So that means there's no reaction. And then Al3 plus and NO3 minus, Ag plus and O2 minus. I successfully made my precipitate, and we are good to go. So that is your wife swap, your double replacement reactions.